And if you look right here, I took a picture of 18 through 27. Now, these are all different. All right, so don't memorize these because on the test they're close, but they are different. So you should already have used the paper and hopefully have a good idea of how to name these. So I'm just gonna, well, maybe I'll just type. Never mind, it won't let me type and talk at the same time, so that's fine. So 18 is an acid. Oops. Write it up here. It's an acid because it starts with an H. It is NO2. You should know that nitrate is NO3. One less than the nitrate would be nitrite. And the acid that comes from an ite is an us. So we're going to say nitrous acid. These are hard to draw, so just be patient with me. This one, it's just an ionic compound, so you name the metal and then the polyatomic ion. So sodium phosphate. I'm not going to try and get it all out. Phosphate, and just deal with it. All right, this is another ionic substance, number 20. So I name the metal, copper. Then this Roman numeral will tell me the charge up there, so it's a 3. And then we name that, which is acetate. All right, then number 21. Lots of kids don't memorize ammonium, and they should. It's ammonium, and then just oxygen is oxide. All right, so ammonium oxide. Hopefully you're doing okay on these. I know you can't read my writing, but oh well, get over it. Nitrogen dioxide. These are both nonmetals, and it gives me a prefix. So nitrogen, and then the prefix goes on the thing that is listed after it. Sulfuric. Ic acid comes from the most common polyatomic ion. So for sulfur, it is SO4. So HSO4, but sulfur is a -2, sulfate I should say, so it's H2SO4. Potassium chloride, it's K, and chlorite comes from chlorate, which is ClO3. It's an ite, so it's missing one, so potassium chloride is KClO2. This is a +1, this is a -1. All right, so KClO2. Sorry, I got interrupted there. Lithium hydroxide, LiOH, +1, -1, so it's just LiOH. Ammonium sulfate. Ammonium, we just set up there, was NH4. Sulfate is SO4. This is a -2, so +1. So NH4, parentheses 2, then SO4. Tungsten 2 nitride, so a W for tungsten. And then the 2 tells me this is a +2. Nitride is an N, it's a -3, so W3N2. All right, I hope that you're okay with that. Let's look at the next section. Okay, the next question on the test will be very, very similar to this. Everything has been changed, so it's not the same, but if you can do this problem, then you can absolutely do the one on the test. There's one already like this worked out online. Let me see what number it is, or where it is. All right, it's on the web page. If you go down towards the bottom, it'll say limiting reaction examples. Then it has your practice problem. Then another one that says this problem is no longer in the book, but may help. It's one that's not there, but it's one I'd worked out and talked you through this entire process. So we'll do this one pretty quick, but not as in depth as I've done it on all of the others. All right, there's no way I can fit the reaction into here, so I have it right here on the next page. So 2 sodium hydroxides, 1 copper 2 nitrate go to 1 copper 2 hydroxide and 2 sodium nitrates. All right, so that's the balanced chemical equation. Next would be the molar mass of each component. I like to break this down so it's pretty simple for me to grade and pretty simple for you to not mess up. So let's go ahead and look at those. And as always, I round. So this is about 40 grams per 1 mole. Copper 2 nitrate. Looks like it's 187.5 grams per 1 mole. Copper 2 hydroxide is 97.5. And sodium nitrate is around 85. So this would be the answer to A, the balanced chemical reactions, and B would be all of these. All right, let's look at the next part. Next up, it asks for the limiting reactant. All right, to determine the limiting reactant, I'm going to use the second way that I told you, and it doesn't matter what way you use, but I know I'm going to have to solve for this anyway, so I'm just going to kill 2 birds with 1 stone. So I'm going to come to another page again, and we're going to start 2 picket fences. My picket fences are going to be ugly, but let's see, I have 6.25 grams of sodium hydroxide. So that'll be 1 picket fence. And I'm going to solve for either one of my 2 products, but I'm going to make both these equal to the same product. So grams of sodium nitrate. All right. So I start with both of my given masses. So one was 6.25, one was 3.00 grams. And that was of copper 2 nitrate. Now I'm going to cheat just because I can't write all this, so I'm going to put just copper plus 2. All right, now, I shouldn't do that, but whatever. So down here, I'll write the whole thing. CuNO3, 2. And down here, I'm going to put grams of NaOH. It doesn't look like it. It's terrible, but it's NaOH, and that's 1 mole. NaOH, and this is 1 mole. CuNO3, 2. All right, now I'm going to have to get really tight here because I want to end up with NaNO3 on both of these. So what I'll have on the bottom is my moles of NaOH, and if you go back to the balanced chemical equation, you will see there's a 2 right here. All right, so 2 mole NaOH per every mole of NaNO3. And you go back, and once again, there's a 2 there also. Whoops. So I'm going to put a 2. So all I need to do is go back and put in my grams of what NaOH is, and it's right here. It's 40 grams. And then I'm going to do the same thing here. I'm just going to cheat here. With my Cu, I had 1 mole Cu plus 2 for every 2 mole NaNO3. And I can't erase, unfortunately. So, I never even finished that one up top. I just realized. Now for on the bottom, I'm going to have 1 mole NaNO3, and I need to know its mass. NaNO3 is 85 grams per mole. I need the little mass of copper 2 nitrate. I found it is 187.5. You can't see the 8 or the decimal, but I promise they're there. Then over here I have 1 again on top, or sorry, 85 on top and 1 on the bottom. This is a disaster. I hope I'm not losing too many of you. All right, for that answer I got 13.28. For this one, I get 2.79. So it is obvious which one of these is a small number. So I'm going to completely ignore all my math here, because this is my limiting reactant, my CuNO3 2. All right, so now I already have 2 answers that it wants here. All right, so this is where I want all your answers. You can put them right here. So we just learned right here that our limiting reactant was copper 2 nitrate. So already I can put a 0 in for my value of copper 2 nitrate. I also solved for grams of NaNO3 and got 2.79. So I'm going to put 2.79, and that will be the answer for that. So now I need to figure out the sodium hydroxide and the copper 2 hydroxide. All right. I'm going to start first by solving for one of my products. The only other product I have left is grams of copper 2 hydroxide. So I'm going to start with my limiting reactant. That was 3 grams CuNO3 2. All right, then I'm going to have grams of CuNO3 2 per every 1 mole. CuNO3 2. I know you can't read it, but hopefully you can hear it. Then I need to go from CuNO3, so I'm just going to put NO3 here and OH up here. Hopefully you know there's the Cu in the brackets and all that. But in front of both my coppers, I had a 1, if you remember. So it's 1 mole to 1 mole. Now, the grams of CuOH 2 per 1 mole. CuOH 2. I just need to go back a few slides. I found the mass of that. Sorry, my English is sucky right there. 97.5. Just going to put that right here. I also need to find the mass of copper 2 nitrate. And it was 187.5. Oops. Okay, now, if I plug that in, okay, most of you probably already noticed while I was writing it, but I wrote this upside down. I needed mole on the bottom, and then the grams on the top. So up here's my 97.5, and down here's my 1. Sorry. I'm sure that you had that before I noticed it. So I solve that problem, and I get 156 grams, or 1.56 grams. So let's go ahead and put that in. All right, the last thing that we need to figure out is just our sodium hydroxide, which is our excess reactant. All right, so let's go ahead and figure that out. First, I need to find how much we started with. Oops. So our start of sodium hydroxide was equal to 6.25. Now I'm going to use a picket fence again. 3 grams. I'm going to solve for grams of NaOH. This was CuNO3 2, 187.5 grams per 1 mole. CuNO3 2. For every 1 mole CuNO3 2, I have 2 moles NaOH. For every 1 mole NaOH, I have 40 grams NaOH. Now, remember, this is not going to be your answer. I'm going to take this and subtract this number from it. All right, when I get this number, it's 1.28. So now I'm going to take 6.25 and subtract 1.28, and that will give me my value. And it is 4.97. So I'm going to come back here. I'm going to put in 4.97. Now, just a quick check. Add those numbers together and they should equal your starting mass. When I add them together, I get a little bit more than the mass we started with, but with my rounding, I got 9.32. We started with 9.25. Due to my rounding, I'm going to say that is good enough. So I believe I'm set. All right, I'll review this last problem on a different review video.